Okay, welcome back. This is part D. In part D, we are going to integrate this what we call bracket ax plus b power n. Okay. Now before I start, okay, let me just inform you that for integration, basically you have only about two formula. Okay, basically one is the xn dx. Okay, integration of xn. This is simply xn plus 1 over n plus 1. Okay, and then of course there's an arbitrary constant. Now the second one would be actually this one of this format. This is actually ax plus b, right? Ax plus b actually is a polynomial of degree 1 or linear. Okay, and then of course there's no dot here. Okay, dx. Okay, so here we're going to get ax plus b n plus 1 over a n plus 1 plus c. Now this is the second one that you need to know, where I'm going to actually prove to you. Okay, now the proof is actually not that difficult. Okay, let me just get the proof up. Okay, let me just show you how we get that. Now initially, let's try to integrate this. Let's try to differentiate this. Okay, this one actually you know that we get this. Okay, you bring the power n plus 1 and then ax plus b. Okay, and then the power n plus 1 minus 1, and then you actually have the chain where you differentiate ax plus b. So this will give you this. Okay, now if this is true, right, then this must be true also. Okay, so if you differentiate this, we get this. By definition, you integrate this, you must get back your integrand here. Am I right? Okay, and you also know that a n times n plus 1 is actually just a constant. You can actually bring them out, and if you were to divide a times n plus 1 on both sides, you're going to get this. Okay, let me just go up. Okay, now this is the second integration that we need to know for polynomial. Okay, again, please take note we need to know only two, as I mentioned just now. Okay, which is these two. Is there a formula if the integral here inside here is non-linear? For instance, is there a formula where it is ax squared plus b power n? Okay, there's no formula actually. Okay, there's no formula as you can see for the linear. However, this doesn't mean that there's no function for this integral. Okay, we can do it in another method. Okay, but there's no formula, so please remember there's only 1 and 2. Sometimes they put a here. Okay, if this is true, then here will be times a. That's all. Okay, so here there's none, no formula. Okay, now let's look at, oh no, okay, let's look at this tree. Okay, this example here. Let me just show you the example. Okay, now we're going to integrate this. Okay, so how do we actually do this? Okay, look at the first one. Okay, I'm going to actually cover here. Okay, we inspect. This is actually a linear of the form ax plus b. Okay, this is part 1. Okay, so we're going to get this. Okay, how do I get 5? Okay, basically we got power 5 because remember it is n plus 1. It is this, correct? After doing some time, right, you know that you can actually do from here to here, rather this to this, and then from here to here. Okay, but as you are now starting, right, I prefer you to actually write this one first. Okay, this step first, and then followed by this step, not the other way around. That's what I do here. Okay, now, and then if you were to simplify this, we are going to have this and remember the constant C. Okay. Now for part 2, right? For part 2, we are going to have this. Okay. This is part 2. Okay. Now for part 2, right? We can actually write the integration something like this. Please take note. For the formula integration of ax plus b power n, right? Now n is any rational number except -1. Okay, n is any number, n is real. Okay, any value except n equals to -1. We will deal with n negative 1 later. Okay, so we can write something like this, and same idea. We are going to -12 plus 1 here. -12 plus 1. Remember, there's a 2 here. Remember? Okay. Remember the formula. The formula, if you were to take note again. Okay. If you were to integrate ax plus b power n, this ax plus b will be n plus 1, and then we divide by n plus 1, and then you divide by a. A is actually the coefficient of x. Okay. So in this, right, the coefficient of x is 2, so we divide by 2 and we divide by n plus 1. So we're going to get this. Okay. And you know the denominator will be 1, so we're going to get this. Okay. And we need to write the plus c. Okay. Now we go to the last part. Okay. Okay, the last part is this. Let me just bring up to you. Okay. Now this is the last part. Okay. It looks like this is not like the form of ax plus b power n. However, it is. If you were to do this, we know that by your indices law, this is true. And 4 power 3 is actually 64. We can bring it up because it's just a constant, a multiple constant, multiple of this integration, Okay, and 2x minus 3 power 3, I can rewrite as power -3. And again, we do the same thing. Okay, this is 64, 4 cubed. 2x minus 3 plus 1, minus 3 plus 1 is -2. So we divide by the n plus 1 is -2, and we divide by the coefficient of x here is 2. Okay, and we simplify, we're going to get this. Again, there is an arbitrary constant. Okay. Let's look at this. Okay, this question. This is example number 7. Okay. Okay, can you read example 7? Dimension there is a gradient of a curve. Okay. And the gradient is given by dy dx, 2x minus 1 power 3. The curve cuts the y-axis at 0, 3. Find the equation. Now, this is what we plan to do. Now, we write, this is the gradient function, remember? This is from your differentiation. And now we learn how to integrate. Now, this is another way to write. If I were to integrate both sides, okay, I will get this. And you know, by definition, you integrate and differentiate y with respect to x, you're going to get y. Okay, so now we're going to work on the right hand side. Again, this is actually quite simple. Minus 2x minus 4, 3 plus 1 is 4, and then divide by n plus 1 is 4, and then divide by 2. So we're going to have this. Okay, now we know that this is true. It passes 0, 3. Okay, so we can find the value of c. We substitute 0, 3. X is 0, y is 3. And we can find c is equals to 23 over 8. That's why y is this. This is the equation of y. Now you can pause now because for example number 8, okay, it's actually quite similar. Okay, you pause now, you do, and you check whether you can find this. Okay. Now last of all, right, this one. Okay, Now from differentiation, you must know how to do this. Okay, let's say you know part 1 already. Okay, so how to do part 2? There are 2 ways I'm going to share with you. Now if this is true, if this differentiation gives you this integration of this will will give you the function 2x over x plus 1. Okay, this is by definition. This is going to be true. Okay, sorry. Okay, so now after that, you look at the question. The question says there's a 1/4 here. Okay, so you put 1/4, you manipulate, and then you bring. And this is actually what the question wants you to do. And therefore, you simplify this, you're going to get this value. This is how you do for part 2. And of course, the arbitrary constant you're going to add. Now, for method number 2, right? Okay, we're going to write the question. And then we're going to manipulate from here. If this is true, I can take out 1/4. Because 1/4 is just a constant. And I know that from definition, from my part 1, okay, I get this, right? Okay, so in my part 2, if I were to integrate this, I get back this. And then when I simplify, I'll get this. Okay, and both methods is the same, I'll give you the same answer. Now, after that, there's some homework. Okay, I want you to do from number 10. Because you already done this earlier. Okay, and I want you to do from number 10. Let me just check whether I'm right. Okay, 18.1, right? Okay, number 5 you have already. Okay, I want you to do from number 10. 10, 12, 13, 16 and 18. Okay, now thank you very much.